Today I want to look at reduction formulae, and the secret is in the word reduction. We're going to make things smaller. Well, let's first look at something that you should be able to do, the integral of x e to the x. How would you do that? I hope that you are very quickly suggesting that I should integrate by parts. Fine. How would I integrate that? You should be telling me that you would integrate by parts twice. Integrate by parts 3 times. Oh dear, we don't really want to have to integrate by parts 8 times. So what we're looking at here is a way of dealing with something like the integral of x to the n e to the x dx. And this I'm going to call in, and I'm looking for a formula which gives me in terms of in minus 1, or a smaller value, reduction. Well, integration by parts is still the way to go. Let's start off with u equals x to the n. U dashed now is n x to the n minus 1. V dashed is e to the x. V is e to the x. Reduction formula, so it makes sense to take u as x to the n, so we then reduce the power of x. Stick this in. uv is x to the n e to the x minus the integral of v e to the u e to the x times du by dx, which is n x to the n minus 1 dx. And you'll see that we've actually written that in is x to the n e to the x minus n minus 1. And there is my reduction formula. Let's see how we can use this in practice. Take a fairly small number so that it's not too awkward. Let's look at I4. That is equal to the integral of x to the 4 e to the x dx. And that is equal to, using the formula, x to the 4 e to the x minus 4 I3. Take that on. X to the 4 e to the x minus 4 times I3. I3, using the formula, is x cubed e to the x minus 3 I2. X to the 4 e to the x minus 4x cubed e to the x minus is plus 12 I2. I2, using the formula, is x squared e to the x minus 2 I1. X to the 4 e to the x minus 4x cubed e to the x plus 12x squared e to the x minus 24 I1. Using the formula, that's x to the 1 e to the x minus 1 times I0. And I0 is the integral of x to the 0 e to the x, which is just the integral of e to the x. And so that's e to the x, giving us x to the 4 e to the x minus 4x cubed e to the x plus 12x squared e to the x minus 24x e to the x minus is plus 24, I0 is e to the x plus c. Still a little bit tedious, but better than doing integration by parts on each single line. Well, let's take this on. What happens now if we look at In equals the integral from 0 to 1 of x to the n root 1 minus x dx. Just pause the video and try this one for yourself. Well, I hope you managed it. Let's just do it in case you didn't. We're going to integrate by parts. We choose u is x to the n. It's a reduction formula, and we want to reduce the power of x. That means that v dashed is 1 minus x to the half. V must have come from, therefore, 1 minus x to the 3 over 2. If I differentiate 1 minus x to the 3 over 2, I get 3 over 2, 1 minus x to the half times minus 1. So I need minus 2 over 3. This is equal to uv minus 2 over 3 times x to the n, 1 minus x to the 3 over 2. There's uv. A lot of people don't bother about the limits. They're a bit silly if they don't. Minus the integral of v, which is minus 2/3, 1 minus x to the 3 over 2 times n x to the n minus 1. Well, we are aiming, put the limits in, we are aiming at the integral of x to the n minus 1 times 1 minus x squared to the half. So my tip here is to rewrite the integrand with this first. Let's see what happens. And now you can see why I said that you shouldn't ignore the limits. If we put x equal to 1 in this bracket, we get 0. If I put x equal to 0, we get 0. So that first term just becomes 0. Plus 2n over 3 integral 0 to 1. Let's see what we've got here. We were wanting to write x to the n minus 1, 1 minus x to the half. And if I write that, what have I got left? I still want to multiply by 1 minus x. 1 minus x times 1 minus x to the half is 1 minus x to the 3 over 2. So now let's take the 1 and multiply. That will give us 2n over 3, integral 0 to 1. Taking the 1, I get x to the n minus 1, 1 minus x to the half. Now if I take the minus x times x to the n minus 1 is going to be minus x to the n, 1 minus x to the half dx. And this tells us, this has been working out In, that this is 2 over 3 times n. My integral now, the first part is just n minus 1, and the second part is In. So I now have an equation for In, adding 2n over 3 to both sides. I get 2n plus 3 over 3 In is 2n over 3 In minus 1, and that gives us that In, 3's cancel, 2n over 2n plus 3 In minus 1. Let's have a look at this one. It looks very similar to the previous one, but I've got 1 minus x squared now in the square root sign. I would like you to pause the video and see if you can sort this one out for yourself. You should be aiming to use integration by parts, and remember it is a reduction formula. Well, did you manage to do that? Once again, I will do it for you, for those of you that didn't actually manage to do it. The first thing to notice is that if we want to integrate by parts, we actually need an x with my 1 minus x squared to the half. When I'm looking at v dashed is x 1 minus x squared to the half. Unless I put the x there, I can't actually cope with v. That must have come from 1 minus x squared to the 3 over 2. And if I differentiate that, I get 3 over 2 times 1 minus x squared to the half times minus 2x. So I get minus 1 over 3. And the other bit of it is going to be x to the n minus 1. If I put u equals x to the n minus 1, then u dashed is equal to n minus 1 x to the n minus 2. This gives us uv, which is minus 1 over 3 x to the n minus 1, 1 minus x squared to the 3 over 2, between 0 and 1, minus the integral of v, which is minus a third, 1 minus x squared to the 3 over 2, du by dx is n minus 1 x to the n minus 2, between 0 and 1. We get 0 in the first bracket, and we play the same trick as we did on the previous one, that we're going to rewrite 1 minus x squared to the 3 over 2 as 1 minus x squared to the half, because that is what comes into in, times 1 minus x squared dx. That is n minus 1 over 3, integral 0 to 1. Taking the 1 in, I get x to the n minus 2, 1 minus x squared to the half, minus x squared times x to the n minus 2, 1 minus x squared to the half dx. And now I have that in is n minus 1 over 3, n minus 2, minus n minus 1 over 3, in. That tells me that adding the n minus 1 over 3 to both sides, I get n plus 2 over 3 is equal to n minus 1 over 3, n minus 2, which tells us that, I lost the in is equal to n minus 1 over n plus 2, n minus 2. Did that quite quickly. You'll be able to find this in the notes if you need to look at it more slowly, or you can pause the video and read it through more slowly for yourself now. I'll stop this video now. I've got 2 more examples to do. They'll be in the second part of the reduction formulae videos.